We take electricity from somewhere where it is common and easily available, and with a laser we convert that into light. That light is then sent through an optical fiber cable where it then travels to the remote device where our power receiver takes the light and converts it back into electricity of the exact style that the receiver needs.
Typically, we think of energy as electrons traveling through metals, copper, aluminum. What we need to think of is energy as photonic energy, as photons traveling through optical fibers.
Power over fiber is a concept that I've been chasing for over 20 years. It's a notion of being able to deliver power from point A to point B without having a conductor in between. If I could do that, it would remove a significant constraint in the design space for every system that we have. If you want to deliver the power inside or outside of the system, it required a conductive path. It makes engineering a complex system a whole lot simpler.
We've received interest for a lot of different use cases for power over fiber. Telecommunications devices need to have this electrical isolation and easy deployment of power. Researchers need isolated power for high voltage environments. On the defense side, the increasing use of underwater vehicles is enabled and expanded by providing power through fiber to those underwater vehicles.
Power over Ethernet, as it currently exists, provides you with the opportunity to have a distributed network over, at most, a couple hundred feet. If you implemented the same basic protocol with power over fiber, you could have a network system that does exactly the same thing and more, but over tens of thousands of feet. That's huge.
We're now eliminating a lot of the issues with electrical systems, such as grounding. In a marine environment on Navy ships, grounding or loss of the ground because of corrosion is a major problem with electrical devices. With a power over fiber system, you will not have that issue. Everything around us, all these electronic devices that we have transmitting, Wi-Fi and so on, there's quite a bit of EMI devices affecting the performance of other devices through EMI, through these signals.
If you're not using copper wire, in this case you're using fiber optics, which is a dielectric, it's immune. It's naturally immune to the EMI. So that problem just disappears.
Powerlight has achieved multiple milestones for power over fiber, as well as free space wireless power beaming with customers in the government and industry, setting multiple world firsts and world records in delivering power in ways and power levels and distances that have never been done anywhere else in the world.
This is not a research effort. This is truly a development and implementation effort.
Now we're in a place where we can actually start to think about not only sending the data in our communities at very, very high data rates, but we can also send large amounts of power to distribute that data, and all with the same basic infrastructure. That is likely to change our whole cityscape, our whole design of clusters of where we live and how we live in ways that we can only just imagine.